right. So thank you everyone for joining us today for this special P2 Week webinar on actionable strategies for general industries and national emphasis areas. So we will be recording this session, and those who haven't been able to join us, we will share the recording of this webinar with them as well. So my name is Farzana Islam, and I'm a research engineer at West Virginia University's Department of Industrial and Management Systems Engineering. And during today's session, we will explore the key principles and strategies of pollution prevention, focusing on proactive methods to reduce and eliminate waste and pollution at its source, focusing on general industries and NEAs. And you will also learn about the tools and resources provided by EPA that can help industries implement these strategies more effectively. So we will begin with an overview of pollution prevention, followed by the discussion of the benefits and the strategies of P2 that can be applied to the general industries, and then we will hop on to the NEA-specific P2 best practices, and finally we will show you some EPA tools and resources. And those who have attended our workshop on P2 a couple of weeks ago, few of the initial slides might look similar, but we have absolute new content for the NEAs in the later part of the presentation. So let's start by defining what pollution prevention is. At its core, P2 is any activity that reduces, eliminates, or prevents pollutants or waste at the source before they ever have the chance to cause harm. This is crucial because it allows us to address pollution proactively rather than reacting to the consequences after the fact. Now, when we talk about managing waste and pollution, there is a hierarchy of strategies we can employ, ranging from most preferred to the least. These are prevent, reduce, reuse, recycle, recover, and dispose. First and foremost, prevent. This is the gold standard of pollution management. If we can prevent pollution from happening in the first place, we eliminate the problem before it starts. This approach is the most effective because it tackles the issue at its root. Next is reduce. When prevention isn't possible, the goal is to minimize the amount of waste or pollution generated. This could mean using less material in production or finding ways to make processes more efficient. Reuse comes after reduction. If we cannot avoid creating waste, the next best option is to find ways to reuse materials, extending their life cycle and keeping them out of the waste stream. Following reuse is recycle. Recycling allows us to transform waste materials into new products. While recycling is better than disposal, it is still less ideal than reusing because it typically requires energy and resources to process the waste. Recover is next in line. This involves extracting energy or other resources from waste. While it recovers value from the waste, it still means the material is not being used in its original form, making it a less preferable option. Finally, we have dispose. This is the last resort. Disposal should only be considered when all the other options have been exhausted, as it means the material is ultimately lost and often ends up in landfills, contributing to environmental degradation. So the goal is to move up this hierarchy as much as possible, focusing on prevention first and only considering disposal as a last resort. Now let's dive into the main focus of today's webinar, pollution prevention strategies for general industries and more tailored industry-specific practices. This is where we have the opportunity to make the greatest environmental and economic impact, particularly in key sectors that have traditionally been resource intensive. So let's take a closer look at how these practices can be implemented and the tremendous impact they can have. So here are 5 key methods of pollution prevention that we'll be focusing on next few slides, which includes redesigning products, choosing alternative input materials, Switching to other equipments, improving process monitoring, adjusting concentration levels of any chemicals being used. So when we talk about redesigning products as a method of pollution prevention, we are focusing on ways to fundamentally alter the design of a product to minimize waste and environmental impact. This can be achieved through several strategies. First, let's consider reducing material use in packaging. For example, in the food and beverage industry, companies can redesign their packaging to use less material, whether that means using thinner plastics or more efficient shapes. This not only reduces the amount of waste generated, but also lowers the cost of the material. Next, we have reducing component variety in industries like automotive manufacturing or in any other manufacturing industry. Standardizing components across different models can reduce the number of different parts that needs to be produced and stocked, leading to less waste during manufacturing and easier recycling at the end of the product's life. And finally, integrating modular design is a powerful approach. For instance, in aerospace product and part manufacturing industry, companies can design parts that are modular, meaning they can be easily replaced or upgraded without needing to replace the entire product. This reduces waste and allows for more efficient use of materials over the product's life cycle. Another crucial method for pollution prevention is choosing alternative input materials. This approach focuses on replacing conventional material with more sustainable and less harmful alternatives to reduce the environmental impact of manufacturing process. One example is to use alternative source of energy to supplement the grid. Companies can integrate renewable energy sources like solar or wind power into their operation, which reduces their reliance on fossil fuels, lowers greenhouse gas emissions, and can even reduce operational costs in the long term. Another example is to use biodegradable materials. Companies can opt for packaging made from biodegradable materials instead of conventional plastics. This not only reduces the waste, but also minimizes the environmental impact when the packaging is finally discarded. And finally, switching to non-toxic solvent, which is another powerful strategy and can be heavily applicable in chemical manufacturing industry. Replacing traditional and hazardous solvent with non-toxic alternatives can significantly reduce the release of harmful chemicals into the environment and improve worker safety. Another effective method of pollution prevention is switching to other equipment. This approach involves replacing or upgrading existing equipments with more efficient or environmental friendly alternatives. One example is to install energy efficient motors. Upgrading to energy efficient motors can significantly reduce electricity consumption as it's a load driven device and lower greenhouse gas emissions. This not only helps with the environment, but also cuts down on energy cost for the company significantly. Another example is to use airside economizer in HVAC system. This is relevant to any industry where climate control is crucial for maintaining the quality of the components. An airside economizer reduces the need for mechanical cooling by using the cooler outside air when conditions allow, leading to substantial energy savings. And finally, using low-flow water fixtures is a simple yet effective way to reduce water usage, and this approach can be applied across various industries, including those covered by food and beverage, manufacturing, and processing. By reducing water flow, companies can lower their water bills and minimize their impact on local water resources. Improving process monitoring is another key method of P2, and it involves closely tracking and managing the various processes within the facility to reduce waste and improve efficiency. And one example is to implement continuous emission monitoring systems. CEMS can play a crucial role in tracking emissions in real time, allowing companies to quickly identify, allowing them to address any issue that arises across the industries. This helps ensure the compliance with environmental regulations and reduces the overall environmental impact. Another example is to adopt predictive maintenance. This is particularly for many manufacturing industries. By using the data and analytics to predict when equipment will need maintenance, companies can prevent unexpected breakdowns, reduce downtime, and avoid the waste associated with emergency repairs. And lastly, regulating compressed air usage is a simple but effective way to improve efficiency. In automotive manufacturing, for example, compressed air systems are often a major source of energy consumption, and by carefully monitoring, regulating their usage, and assessing whether they're required or not, companies can reduce energy waste and lower operational cost. And the last effective method for P2 is adjusting the concentration level of chemicals. This involves fine-tuning the amount of chemicals used in various processes to reduce waste and to minimize environmental impact. One example is to optimize chemical usage in cleaning process. Reducing the concentration of cleaning chemical can lead to less chemical waste, lower cost, and a reduced risk of harmful chemicals entering the environment. Another example is to adjust the pesticide concentration in agriculture. Optimizing pesticides use can protect local ecosystems and water sources from contamination while still effectively managing pests. And finally, optimizing cooling water treatment is a crucial step in industries. By carefully controlling the concentration of treatment chemicals, companies can maintain the efficiency of their cooling system while minimizing chemical use and reducing the potential for environmental harm. While these methods I just described are key strategies for pollution prevention, it's important to remember that P2 is not limited to these approaches. Pollution prevention often requires us to think creatively and explore unconventional solutions. Sometimes the most effective strategies are the ones that aren't immediately obvious, and they might require us to challenge traditional thinking or to consider entirely new ways of doing things. And yeah, so I want to demonstrate this concept of thinking outside the box with this simple yet powerful puzzle, which is here you can see the 9 dots. And if I ask you to connect all the 9 dots with 4 straight lines without lifting your pen from the paper, at first, most of us will instinctively try to solve the puzzle by staying within the line and within the boundaries of the dots, which is within the box. But as many of you might find, it is impossible to connect all the dots this way. The solution only becomes clearer when we allow ourselves to break free from that conventional thinking, when we realize that nothing is stopping us from drawing the lines outside the perceived box. This is what we mean by thinking outside the box. And in pollution prevention, the most impactful solution often require this kind of creative thinking. And it is about pushing boundaries and challenging assumptions, finding innovative ways to reduce waste and minimize environmental impact. And now let me share with you a fascinating example of out-of-the-box thinking that truly embodies the spirit of P2. Which is in 2009, Google hired a team of 200 goats to mow the lawn at their Mountain View headquarters. Instead of using lawnmowers that emit pollution, Google decided to bring in these goats to graze and naturally trim the grass. Not only did this solution reduce the emission, but it also saved on fuel and maintenance costs associated with traditional lawn care equipment. Additionally, it provided natural fertilizer for the grounds and contributed to a healthier ecosystem. Now let's briefly look over the 6 NEAs that has been prioritized by P2 program before we jump into the NEA specific recommendations or strategies. So we have NEA. The first NEA is food and beverage manufacturing and processing. The second one is chemical manufacturing, processing, and formulation. Then we have automotive manufacturing and maintenance. Next is aerospace product and parts manufacturing and maintenance. Then we have metal manufacturing and fabrication. And finally, we have supporting pollution prevention in Indian country and for Alaska native villages. So let's first jump into the P2 best practices for NEA 1, which is food and beverage manufacturing and processing. So here we have listed few best practices here, which we will explore better and dive deeper into how they work and the benefits they bring to the food and beverage manufacturing in the next few slides. But first, let's understand how important refrigeration is for the food and beverage industry. Refrigeration is crucial for food and beverage industry, which heavily relies on the temperature control to ensure quality and safety. And here are 4 points we have listed down here why it is so important for this particular NEA. The first is in food and beverage industry, maintaining controlled temperature is essential to extending the shelf life of perishable goods. Proper refrigeration helps prevent spoilage and contamination, ensuring product reach consumer safely and with optimal quality. Many processes in food production, such as fermentation, chilling, and freezing, require precise temperature control. Effectively, refrigeration ensures that these processes occur within the correct parameters, safeguarding both product quality and safety. Given the energy-intensive nature of refrigeration in the industry, optimizing the systems can vastly improve overall operational efficiency. And finally, food safety regulations require stringent temperature controls throughout the supply chain, and reliable refrigeration systems are key to meeting food safety standards, reducing the risk of non-compliance and ensuring consumers' safety. So one of the solutions for this particular system is using secondary refrigeration system, which is an effective solution to minimize the use of hazardous chemical while maintaining safe and efficient cooling process. So let's have a better look at how this process works. So the process begins with the compressor, which circulates the primary refrigerant through the primary circuit, which refrigerant cools down the heat exchanger. But here is a catch. This is risky because the primary refrigerant, such as ammonia, is toxic and can be dangerous if it leaks. Imagine an ammonia leak in the meat processing plant, and this could result in product contamination, create a hazard for the workers, and cause significant downtime. Primary systems also operate under high pressure, increasing the likelihood of leaks or equipment failure, which is something food and beverage processing companies must be cautious about given the stringent health regulations they face. Now, there comes the secondary refrigerant, which absorbs the cold from the heat exchanger and is distributed throughout the plant, cooling equipment and product efficiently. A jacked cooler you see there ensures that the target substance, whether it's a product or a piece of equipment, is cooled safely, preventing any contact with the primary more hazardous refrigerant. So this is why secondary refrigerant system is better because the primary refrigerant, like ammonia, is kept confined in a small control area of the plant, such as the machine room, and this means the hazardous chemical are not spread throughout the production areas, reducing the risk and exposure. So let's take a closer look at the benefits of using a secondary refrigeration system. First of all, it reduces harmful refrigerant. First of all, it reduces harmful refrigerants, and one of the key advantages of using this secondary refrigeration. Next, it improves safety, the things we discussed in the previous slide, that it can prevent spilling through the storage, or it can prevent any contact with the workers or the food. Next benefit is it is a isolated refrigerant, which is the design of the system ensures that the main refrigerant stays confined within a specific controlled area, which is usually the machine room, and the condenser, while a safer secondary refrigeration circuit circulates throughout the plant. And finally, it is cost effective. Not only does the system improve safety and efficiency, but also cost effective, as the safer operation leads to lower maintenance cost, and the reduced need for refrigerant top-ups minimizes ongoing operational expenses. All right, so now we will discuss about another best practices that this particular industry can consider, which is on-site water treatment techniques. And in a lot of these food processing company or manufacturing units, boilers are essential in food and beverage industry, providing steam for the key processes like sterilizing equipments, pasteurizing products, and supporting cooking and cleaning operations, ensuring the boiler runs efficiently and helps maintain high production quality while minimizing the energy consumption. And one of the very important step here is the makeup water, which is added to replace water lost during the steam production, and plays a critical role in boiler efficiency. Maintaining high water quality is necessary to ensure the boiler operates effectively and avoids scale buildup and ensures consistent steam output. Now, here is a more closer look at reverse osmosis, which is incredible effective method for reducing total dissolved solids, or TDS, in boiler makeup water, especially in the closed loop heating systems. So let's go over why these key practices in this particular industry, like food and beverage, is and how it works. So here is the diagram of the reverse osmosis, and I will walk you through how RO works and then discuss how it directly benefits the makeup water used in boiler system. So the first step is, before water enters to the RO system, it goes through a pre-treatment stage. And here, large contaminants like sediments, chlorine, and other impurities are removed to prevent clogging or damage to the RO membrane. And this step ensures that the membrane can focus on filtering smaller and dissolved solids. And in the next step, as you can see here, the core of the RO process is semi-permeable membrane, and water is pushed through this membrane under pressure. And when water molecules pass through and leaving behind TDS, including salts and minerals and organic contaminants, the clean water that passes through is known as permeate, while the remaining water with concentrated impurities is called rejects. So you might be thinking, what is this semi-permeable membrane and how it works? So a semi-permeable membrane is a key component of reverse osmosis system. So it allows the certain molecule to pass through while blocking the TDSs. So in this RO process, water is forced through this membrane, and only the water molecules pass through, leaving the TDS behind. And these RO membranes are typically made of thin film composite, which is called TFC materials. And these are polymer materials that are designed to have a specific pore size, small enough to filter out the dissolved solids, but large enough to allow water to flow through. So as you can see, RO is not only effective, but also cost efficient, as it is energy saving solutions that can significantly reduce the operational cost of the boiler over time. And for instance, in one case study, a company using RO technology saved an impressive 68,000 therms of energy and saved more than $30,000 per year. And this demonstrates that beyond its environmental benefit, RO can also result in substantial financial savings, as it helps with the boiler makeup water, which helps to keep the boiler scale free. And here are some few other techniques to save water in the facility, which is used throughout this food and beverage manufacturing units or businesses. And I'm not going over one by one due to the shortage of time, but it discusses about the reuse of final rinse water, reuse of scrubber water, reuse of brine, considering low flow faucet and aerators, and regular inspection to keep an eye out for leakages and waterline spillage. Next, we have another recommendation for this particular industry, which is utilization of byproducts. And we have listed down many points here suggesting extracting valuable compounds from different byproducts, such as mango peels, tomato byproducts, and looking for ways to convert food processing leftovers to repurpose them, such as animal feed, and also looking for opportunity to partner with specialized industry to extract useful byproduct if in-house extraction or repurposing is not feasible. But here I want to slip in one of my personal experience. So this is when I was working with a manufacturing company, and we implemented a byproduct management strategy that truly revolutionized our production line. We were able to repurpose byproduct as an additive material in the production process, which ultimately replaced a significant amount of raw material. And not only did this save us a substantial amount of money, but also it contributed to the company's ESG goal by reducing waste and enhancing sustainability. It was a great example of how smart, well-planned strategy can turn a challenge into benefit. And next, we will talk about our NEA2, which is chemical manufacturing, processing, and formulation industries. Here we will talk about the implementation of proper chemical storing plan practices and transfer plans, and how optimizing reaction conditions can help with reducing the release of toxic chemicals, very briefly. So these are the list of some best practices, or the things we can keep an eye out for to ensure that we are doing proper chemical storing. So the first one is classifying and storing incompatible chemicals separately. And next, we can consider maintaining environmental conditions such as temperature and humidity. We should also label containers properly and replace damaged labels immediately if the situation occurs. And we should also consider storing unused chemicals in separate containers to avoid contamination. And also, we encourage to perform routine checks of storage conditions and avoid exposure to sunlight, water leaks, and mechanical or electric shocks, because sometimes exposure to any of this can compromise the integrity of the chemicals, making them dangerous to handle or even causing hazardous reactions. Next, we have some suggestions for preparing proper chemical transfer plans, which includes maintaining proper environmental conditions during transfer, providing training to employees handling chemicals, using automated dispensing systems to reduce manual handling, and using drip pans to prevent spills. And this is very important, and we can look for ways to integrate this to various transfer processes, as drip pans should be placed under the transfer points to catch spills and prevent hazardous chemicals from contaminating the work area. And this simple practice can help contain small spills and make cleanup faster and safer as well. And as some more suggestions we have, ensuring filtered air into the transfer area before exhaust, using pre-weighed sealed containers when possible, cleaning transferring containers properly before using, and conducting safety drills to ensure employee safety so that they learn about how to react quickly and safely in real situations. Next, we have another suggestion for this particular industry is optimizing to reduce the releases of TRI. So when working with, I'm sorry. Yeah. So when working with chemical processes, the byproducts generated largely depends on the conditions under which the reaction occurs, which includes temperature, pressure, catalyst, reactant concentration, and quality. And the key focus should be maintained on optimizing reaction conditions, which is not a one-time task. It requires continuous research to find the best temperature, pressure, catalyst, and other factors that lead to cleaner and more efficient reaction. And the goal is always to find conditions that either reduces or completely eliminates toxic byproduct. And cleaner chemical processes benefit both environment and the company by reducing waste and minimizing hazards and lowering cost associated with waste disposal. So we hope that these practices can help with the overall situation. And next, we have another NEA, which is automotive manufacturing and maintenance. So here we have a list of suggestions, which includes using separate containers for better management of used fluids, switch towards aqueous-based cleaners, and promoting the use of art-friendly products labeled cleaning and degreasing agents. So first is separate, considering separate containers for used fluids. In automotive industry, various fluids are used, and each with its own properties, hazards, and specific disposal requirements. So let's review some of these most common types of fluids, which are antifreeze, brake fluids, engine oil, transmission fluid, and windshield. And the key consideration should include these suggestions, where we suggest that because each of these fluid has different properties, they also require a specific disposal method. Some are flammable, while others can be toxic or corrosive. Knowing how to handle and dispose of these fluids properly is essential for safety and environmental protection. One critical point is that mixing fluids can complicate disposal. When fluids are mixed, they are often needed to be treated as hazardous material, even if some of the original fluids were not hazardous by themselves. So that may increase the disposal cost as well. Such as used antifreeze is generally considered non-hazardous, but if it is mixed with oil or other petroleum-based fluids, it must be treated as hazardous waste. And another consideration should be many of these fluids can be recycled or reclaimed if they are not contaminated. For example, clean antifreeze can be reused or filtered for future use, and engine oil can be recycled into new products. However, this is only possible if we keep these fluids separate and uncontaminated. So here is another strategy for the automotive industry, which is switching towards aqueous-based cleaner. Many solvent-based cleaners used in industry applications contains hazardous compounds like trichloroethane, trichloroethylene, benzene, and xylenes. And these chemicals are either toxic, carcinogenic, or both in nature. So here, some of the key consideration should be that the cost of the disposing of solvent-based cleaner is generally higher due to the hazardous nature, especially disposal methods and facilities are required for these toxic chemicals, leading to increased cost. And in contrast, water-based cleaners are much easier and cheaper to dispose of, making them more cost-effective option in the long run. And another consideration is improving the occupational safety by reducing exposure to toxic and carcinogenic substances. Water-based cleaner significantly improves occupational safety. It lowers the pollution and goes along with the compliance with the regulations. And also it is less hazardous and non-flammable in nature. And another strategy for this particular industry can be promoting earth-friendly agents or eco-friendly brake cleaning or degreasing agents in the workshop, which are environmentally friendly and sustainable, are safer for workers to handle, clean parts without compromising quality, and cost-effective in the long run. Next, we have our NEA 4, which is for aerospace products, parts manufacturing, and maintenance. Here we are going to talk about how using non-hazardous sealant removals and Green Seal certified products can help with implementing the P2 best practices. So in aerospace application, maintaining and repairing parts are often required, often requires the removal of sealant like polysulfide and polythioether. These sealants are critical for ensuring the integrity of the components, but the solvent used to remove them are often highly toxic, and which sometimes includes toluene, methylene chloride, and N-propyl bromide, which can cause headaches, dizziness, long-term exposure to risk, including cancer, and may link to, and they are often linked to neurotoxicity and other harmful health effects. And the solution can be going for safer alternatives by replacing hazardous remover with the safer alternatives like polygon 310, Distone DL, Skylene 1000, and these will provide more toxin-free alternatives while maintaining the performance. And another suggestion is checking out the Green Seal's website. They have they are a nonprofit organization known for developing rigorous standards to ensure sustainability and safety of products. And their standards include GS 36, GS 43, and 34 for adhesives, paintings, cleaning and degreasing agents, respectively. And this, if we replace some of these currently used products with GS certified products, that can help us in maintaining low toxicity, and as they contain no restricted hazardous substance, and they have low VOC content as well, which makes it makes them cleaner and healthier choices for indoor environment. And finally, our last NEA is metal manufacturing and fabrication. Here we can pay more closer attention to use better coating and plating materials and searching for better processes. As an example, jet vapor deposition, chemical vapor deposition, and electroplating, they all kind of provide same level of service in terms of metal coating. And if we take a closer look at how these processes work, then we would be able to find a better alternative and understand which processes we should go for in terms of environmental perspective. So let's start with JVD. JVD is a physical vapor deposition technique where metal wire like aluminum or titanium is heated and evaporated into stream of atoms using a high velocity sonic inert gas jet, often argon or nitrogen. These evaporated atoms are deposited onto the substrate in a uniform thin coating. The gas jet helps control the thickness and adhesion of the coating, which can range from thin films to thicker layer. JVD works at lower temperature compared to CVD, making it ideal for substrate that are sensitive to heat, like plastics or alloys. This process chamber contains substrate that is held under vacuum condition to prevent contamination during the deposition. Next, another comparable method is CVD or chemical vapor deposition. In the CVD process, reactive gases like silane, methane, or hydrogen are introduced into the chamber containing the substrate. At higher temperature, these gases react or decompose to form a solid layer of material on the surface of the substrate, often used to create metal coating, ceramics, or semiconductors. CVD involves a chemical reaction that deposits materials, but it also releases toxic gases and byproducts that can be harmful to the environment and require significant waste management. And another comparable method, which is electroplating, and we all know about this process. It involves placing the substrate in the solution containing metal ions such as nickel, copper, or chromium, and applying an electric current. This causes metal ions to deposit onto the substrate, creating a metal coating. And it's often used to improve corrosion resistance, wear protection, and for aesthetic purposes such as chrome plating. However, this process uses toxic electrolytes and produces significant amount of hazardous waste and heavy metals, which needs to be carefully managed. And all three processes, JVD, CVD, and electroplating, are extensively used in metal manufacturing and fabrication industry to coat metal components, improve surface properties, and enhance performance. So from P2 perspective, JVD stands out as the better option as it avoids the toxic chemicals and waste produced by electroplating, and CVD offering a cleaner and more sustainable methods for coating metals. Another best practice for the sheet metal fabrication particularly is nesting designs. Nesting involves positioning different parts and shapes, or components onto the flat sheet of metal in such a way that the space between the parts is minimized. The goal is to fit as many parts as possible into a single sheet of metal with the least amount of scrap material or waste left over after the cutting process. And if you look at this diagram, you can see how different shapes or parts are arranged on sheet metal. The outer boundaries represent the dimension of the sheet, and the shapes inside are the components that needs to be cut out. In efficient nesting, the parts are placed as closely as possible, almost like a fitting together puzzle pieces, leaving minimal gaps or unused spaces between them. And as Another suggestion for this particular NEA is using better coating and plating materials. So we have discussed about two alternatives, which is substituting hexavalent chromium with trivalent chromium and replacing xylene with oxyl 100 in steel coating. So hexavalent chromium has been widely used in metal finishing, chrome plating, and anti-corrosion coating, and it provides high durability and an effective barrier against corrosion. However, from the environmental friendly perspective, we can look out for this replacement, which is less hazardous for the environment, and in terms of cost, it might be a bit more costly, but it depends on what the organization is looking for. If they're looking for to meet their ESG goals or agenda, then maybe this project can be justified for them financially. Same thing for replacing xylene with oxyl 100, which gives a better and safer option to replace the heavily used xylene. So as we have discussed about different strategies, we have picked for different NEAs. Let's briefly talk about the tools and resources we have in EPA's websites that we can use for tracking or understanding P2 practices better. The first one is P2 calculator. So these calculators are essential for accurately estimating the environmental and economic impact of pollution prevention examples we are looking for to implement. So this is a great tool. And then we have TRA pollution prevention tool, which provides access to data on industrial management systems of toxic chemicals, enabling user to track and analyze the release and management. Next, we have green chemistry tools and safer choice standards criteria, which is very similar. This provides resource to help businesses develop safer chemical choices and processes, while safer choice standards guide businesses in choosing the right alternative in terms of cleaning agents or antiseptic agents. Next, we have the Energy Star Portfolio Manager, which is a great free tool that helps businesses track energy and water consumption and greenhouse gas emissions, which are sometimes a key metrics to understand where your P2 implementation is going and how the project is performing. In that case, this particular tool can serve as a great tool for tracking. So in conclusion, as we wrap up, let's briefly recap the key points. So we first covered the general industry P2 strategies, which are flexible and can be applied across different sectors to help reduce waste, save resources, and support sustainability goals. And next, we discussed any specific P2 strategies which are tailored to specific industries. These targeted approaches offer opportunities to optimize processes and reapply effective pollution prevention methods across the board. And as a part of call to action, I encourage you to adopt P2 practices whenever possible in your home, workplace, organization. Use these tools and strategies we have discussed today to assess, plan, and improve your pollution prevention efforts. And as we were talking about this, these are not a strategy that is one size fits all, and that's where we come into the play. Our team is committed to offering free industrial assessments, on-site training workshops, and various pollution prevention services to boost your efficiency and sustainability. Dr. Ashish Nimbarti, our principal investigator, guides the strategic direction of our project. We have Dr. Chris Moore, our research associate, who contributes extensively in terms of expertise, and I am Farzana, the research engineer here. If you have any question or need support, please reach out to us, any of us, and we would be happy to work with you and discuss the services we provide and more help you with more tailored approach. Here are the references I have used for making this slide. And here is a big shout out to my colleague Sagar Tamilsina. He helped a great deal in putting all this good information together and to make this webinar happen. And here are some great references. I encourage you to go to them and explore more in-depth and explore for more in-depth information. And thank you so much for your time and attention today. I hope this webinar has provided you with few insight into P2 and how it can benefit your organization.